We humans, like all other species, are naturally exploitive. Except that now we have the capabilities, the tools, the energy resources to dominate this planet. What is it about the way we have evolved to think and act that is shaping this world that we have so recently created? Mankind faces a challenge unlike any other in its history. And it's a problem that evolution did not equip us to solve. We are living in a momentous time, facing our most important test ever. Is it even reasonable to believe that we who created the problem in the first place might also be able to stop it? And if so, allow future generations to avoid a desperate and deadly world left to them by us?
Welcome, everybody. My name is John Zavalny, and I'll be our host today as we talk about an intriguing new climate documentary produced by Jim Swift and directed by Susan Kuchera titled The 12th Hour. What I found so intriguing about this documentary was the idea that our human evolutionary past may play a major role in how we think about and react to our warming planet. But before I introduce our guests and begin our conversation about the 12th hour, I'd like to share a little bit of my background. I retired after 30 years as a K-12 public school educator in Los Angeles at the Fauché Learning Center, where I taught middle school science, high school biology, and environmental studies at both levels. My real passion is environmental education and helping inner city students to understand and experience the natural world. My wife and I saw former Vice President Al Gore tape his slideshow that later became The Inconvenient Truth. Once he announced he was going to train presenters, I applied and was accepted, and was trained with the third group ever trained in January 2007. I made it my job to get into as many classrooms as possible and talk to as many students as I could see to educate them about the climate crisis. And I quickly became one of the top presenters in the organization, which leads me to why I'm here today. I work with Michael Knert at the Video Project to provide free environmental documentaries to schools. I provide educational components for the films and do in-person classroom facilitation. I've already introduced several classrooms to the 12th hour. Now, the 12th hour discusses whether or not we as humans are even capable of solving the climate crisis. My guest today may be able to provide some insight as to whether or not we as humans will be able to work out solutions to this crisis. Dr. Ugo Bardi is a professor of physical chemistry at the University of Florence in Italy. And actually, he just told me he retired, so he's not there anymore. But he's the author of a number of books and articles on the subject of mineral resources and their depletion, among which are the 33rd Report to the Club of Rome, a book entitled Extracted and the Limits of Growth Revisited. Ugo's work focuses on promoting a sustainable transition to renewable energy on the basis of a quantitative energy yield analysis. In his blog, Cassandra's Legacy, he examines, among other things like the Seneca effect, biophysical interpretation of the collapse of complete systems. Welcome, Dr. Bardi. Thank you for sharing your expertise with us today. By the way, what time is it in Italy?
Excuse me?
What time is it in Italy?
What time is it? 9 p.m.
Thank you so much for being here.
It's fine to be here. Thank you very much for your interest.
Okay. So I was a middle school and high school science teacher, and I'm not really sure what physical chemistry is, nor have I heard of the Seneca effect. Can you describe a little bit about what these are, maybe in a way that like non-experts like myself could understand?
Well, it's a good question. After a few years in the university, as you correctly said, I retired last month, and now life is wonderful, wonderful life. I can study and think what I want. But you asked me about physical chemistry, so I have had a career in physical chemistry about 40 years, and I should confess to you that I'm not so sure I know what physical chemistry is. What I can tell you that when I was a student, I remember one professor. He was a very interesting person. He said, "You see, guys, physical chemistry is the science of everything that is interesting." And eventually I thought he was right, essentially, because physical chemistry can tell you a lot of things. You can be very specialized and do extremely boring work in physical chemistry. Just to tell you my story, I don't know if you are interested, but just in case, I started my career as a crystallographer. I don't know if you know what is a crystallographer. A crystallographer is someone who works with X-rays or electron beams, neutron beams, to find the molecular structure of substances.
Okay.
It is the most boring part of chemistry. You probably know that chemistry is boring. Everybody knows that. But if you choose crystallography, you choose the most boring section of something which is already hugely boring. So it's a sort of a spiritual exercise. You do something extremely boring. I did that for this reason. I wanted to test myself. Can you do that to be the most boring thing you can think, and try that? And then for a while, because you cannot do that for 40 years. And it is good because physical chemistry can give you this leeway to move from one field to the other. From crystallography, I moved to petroleum chemistry, which is much more interesting. It's a fascinating story. You can do a lot of things. It's dirty. It smells bad, but it is not so boring. Then I moved into airplane engines, which is a lot of fun. Also noisy. And finally, I found the thing I really liked in modeling dynamic systems. Okay, let me explain. Means making models of the world. You try to understand, that's the basic of science, as you know. Science, you try to understand how the world works. And you can do this at various levels. At the smallest level, you do crystallography. Crystallography, you go see the atoms, as they give, 1 atom, 2 atom, 3 atom, and that's you enjoy. And you enjoy that. At the full spectrum of the story, when you go models and you do macroscopic models of the world, the whole world, like the climate models. And that's the most interesting, the most fascinating, the widest thing you can do. And I can tell you that I started this idea some moment in my life. You probably know the story of the study, which was titled, you mentioned it, The Limits to Growth, sponsored by the Club of Rome, and it was published in 1972. 1972, they made the model of the world, what the world was going to be in 50, 100 years in the future. And only recently, I looked back. This is physical chemistry. You see? Actually, I'm a little biased, as you know. Like if you have a hammer, you always try to find something to hammer on. But really, it's I'm not kidding. Somebody wrote a message to me and said, "Professor Bardi, but don't you think that the models of the limits to growth are physical chemistry?" Yeah, they're a good idea. Yes, you're right. They are. They are, because physical chemistry includes a lot of things. It includes physics and chemistry, and normally also biology. So it includes almost everything except theology. But if you really want, you can include that too.
Okay.
Which sometimes I do because I enjoy studying philosophy. And you mentioned the Seneca effect. You see, I have it here.
Oh, okay.
The Seneca effect. And that also, I think, Seneca, the Roman philosopher 2000 years ago, he was a sort of physical chemist too. Okay, that's answer your question, I think.
Yes, it really does. It answers a lot. But what is the Seneca effect?
Seneca effect. It's Lucius Annaeus Seneca, as you know, lived about 2,000 years ago in the during the high times of the Roman Empire, and he happened to be the teacher of Emperor Nero. Nero, who is was not such a good guy. Anyway, I think to be an emperor is very difficult. I never tried that. I don't know about you, but I think it's a very difficult position. You see, if you are a university professor, not many people want to take your job. Also, because that it doesn't happen to you that a friend of yours wants to kill you and take your job as a professor. But if you are an emperor, then it's a risk.
Yes.
You have this risk every day. So they tend to get a bit nervous and a bit. So anyway, Seneca had this pupil called Nero, Claudius Nero, who was a bit unruly, and eventually the pupil killed the teacher.
Whoa.
But before, Seneca had time to study philosophy, to study many things. Seneca was, in my opinion, he was the prototype of the blogger in his time, because he would write in a way which today you could transfer to blogs perfectly. You write in simple sentences with a lot of weight. So one sentence that he wrote in a letter to a friend, he said, "Oh, dear Lucilius, my friend, we all have this problem that increases out of sluggish growth," and translating from Latin, "but the way to ruin is rapid."
Okay.
And that's physical chemistry.
Right.
It has to do with complex systems, because you notice every day things take a lot of time to grow. Imagine you build a house of cards. Takes a lot of time to build a house, and you don't think, and then it goes 1 second.
Right.
This is the Seneca effect. There is also a curve. I can show you the curve. Cartesian curve. You go up slowly, bang, whoosh, you go down fast.
Okay. So growth is slow and collapse is quick.
Well, you want me to say this in Latin? No, okay. Let me remember. Incrementa lente exeunt, sed festinantur in damnum. Okay.
Thank you for that. I appreciate that.
Because I'm Italian, I speak Italian, so Latin is not so difficult for me.
So how does your expertise fit into something like this documentary, The 12th Hour, and into climate change? What is
a lot, because once you have this experience with many systems which are part of the wide field of physics, chemistry, biology, and atmospheric science, and then you can study climate. And I am not a specialist in climate science. I have my personal ideas, many things, but I mean, I recognize the higher expertise of the people who really know about climate science. I can propose my interpretations, my models, the view that I have accumulated over a certain few years of work. We have been working on climate science on various facets. Right now we are studying mainly, very fascinating, tell you the most fascinating things I ever studied in my life. I've been working at not myself, I cannot design a plane, but I can tell you that working at Airbus A380 was fascinating. The largest plane ever built. And I had the privilege to participate, some small section, but working on the relationship of the biosphere and climate is much more fascinating. It opens up so much, such a large viewpoint, such a deep time extension. You start from 4 billion years ago, and then you come all the way to here, and then you keep going another billion years, and you think about what could happen.
Nice.
I mean, that's an unbelievable thing that you can work on.
Okay, so what message do you think the audience will get from this film?
Okay, I can tell you my personal opinion about what is that we are doing now, what is that we are trying to achieve, what is that we did achieve in part, and what we are doing wrong, in my opinion. Okay, personal opinion, we are focusing too much on CO2 as the only parameter that changes climate. No, not just my opinion. There's a line of thought that sees the interaction with the biosphere, with the atmosphere. It's just another extremely important parameter.
Right.
CO2 is important. No, let me not say that it's not. It's we have changed everything in the system by pushing CO2 to levels which we're not seeing on this planet for maybe 10 million years.
Right.
But also, we are affecting climate because we are affecting biosphere. For instance, deforestation. Now, you, John, you are from Southern California. And just before starting this connection, I was asking you, how is it going with rain in California? And you answered, rain, what is it? And it's a fundamental point. You know, when you say we raise the CO2 level, temperature increases, fine. But how about droughts? How about missing rain? Which also in Italy we have the same problem. No, why is that? Is this CO2? And it is not easy. There may be a logic in the fact that increasing temperatures, you have a different pattern in terms of how rains fall. But I will tell you one thing. If one of the most fascinating things I've learned during the past few years is how rain is made.
Okay.
Everybody knows that, right? You have a cloud, you open your umbrella because rain is falling. Now think about that for just a moment. Imagine the sea. You have evaporation, you have clouds, a little wind moves the clouds inland, and the clouds discharge water. But how far inland? That's the problem you have in California.
Right.
It probably rains right on the not even on the coast, on the sea. It rains, evaporates, and cycles from the sea to the atmosphere and back into the sea. So why should rain clouds go into the continents, go inland? And this is a recent discovery, which is about something which is called the atmospheric rivers. Have you ever heard about that?
Oh yes, we've
You know, of course you know. Yes, we have rivers. We know that. How is it that we have rivers going from inland to the sea? If we have rivers in this direction, I have to have rivers in the opposite direction. Otherwise, it will never work.
Right.
So there has to be a mechanism that brings water inland. This mechanism is in large part generated by forests.
Right.
It's fundamental discovery, recent, by not so recent, 10 years maybe, but takes time to percolate into the knowledge of scientists and general public. It is moving. It's a couple of Russian researchers had this idea in the 2007. The name was, one of them was Viktor Gorshkov. He unfortunately is not anymore with us. The other is Anastasia Makarieva, a good friend of mine, and they proposed this idea of the biotic pump. Biotic pump means that the forest trees get together, forming a collective action that pumps water from the sea and takes it inland and causes rain. Now, they were working with the Siberian climate, and they found that water from the North Sea in Europe is on the left side of Eurasia, clouds are pumped all the way to China. That's unbelievable.
It is.
Unbelievable. You have this huge atmospheric river that goes through the whole Siberia, 12,000 kilometers, huge, and makes it rain in China.
Nice.
And you see the problem you have in California. Now, you have it now, but not just now. You probably know that not that long ago, 1,000 years ago, the central United States was occupied by a civilization which was called the Mississippian civilization. They are called also the mound people because nothing is left of them except mounds of earth in the region, some sort of west of the Appalachians. And what happened to them? Mega droughts. A series of mega droughts. Why did they have the mega droughts? Because they deforested the land. They were among the inventors of corn or maize, if you prefer.
Right.
So they thought it's a good idea. We cut the forest, we plant maize, and then we have lots of food. Great idea, but then they discovered they didn't have rain anymore.
Right.
So you see, the system is complex. You don't have just a question, I turn down, reduce the consumption of fossil fuels, which is a very good thing. By all means, reduce the CO2 concentration. But if you don't take care of the forests, the climate will be affected too.
Absolutely. Now, in the movie, you state that it's been said, not a quote from you, but you state it's been said that no city is more than 3 days away from a revolution because of food supply.
And that's a little problem that the Mississippi, you know.
We've seen a little bit because of the pandemic. We've seen the panic buying.
Yeah, we saw that.
Supply chain problems. So
But
this
you
is
see-
like only the tip of the iceberg of what system failures we may see as a result.
Exactly. And just to remain with the United States, as it is the Mississippians, they had this problem. Those mega droughts, they started killing each other. The archaeologists have found remains of battles of people killed. Human sacrifices became fashionable. And here, not yet. I'm not here. I don't know if in California maybe somebody will propose. But it is true. The system is complex, and it is always the same idea, the Seneca effect. You think things are going nicely. You are here, you think everything is, and then bang, and then you go down, and that's the problem.
Okay, so in what way do you think a documentary like this is a useful education tool and impactful for people?
It is an element of trying to explain, to make some cultural views diffuse into the general consciousness, because the real problem we have is that we intended as maybe scientists or teachers or intellectuals, but we are the average people. Doesn't matter. We are very limited in the way we understand complex systems. It's very difficult because even scientists, in my modest opinion, they tend to overemphasize CO2. So CO2. I work also with young people sometimes, and they have been told that the CO2 is evil, which is not. I don't think it is a way to tell the story. CO2 has a good level. We don't know exactly what it is, but it can change a little without being evil. If you exaggerate, then we destroy everything.
Right.
But we need to try at least to try to pass the message of the complexity of the system and on the fact that we humans depend on the biosphere, and the whole climate is affected by the way the biosphere is managed by humans, because there's no doubt that we are an enormously important factor in in changing the biosphere. Another example, just I think I said it in the documentary, not sure that I remember, but about whales. I don't remember, but humans killed most of the whales in a century and a half or so. Not all of them, fortunately, but most of them. And this, in my opinion, had an effect on climate. Because if you go back in time, way back 33 million years ago, John, what happened at 33 million years ago?
I can't answer it. I have trouble answering what happened yesterday.
I know, because 33 million years ago, whales evolved. They appeared. The kind of whales that we call baleen whales, which is enormous mouths, the blue whales, gigantic creatures. And that didn't exist before. Now you see the record, the temperature record, you see at some point goes down. Because there are good reasons, I think, why whales cool the climate. And if you kill whales, you warm the earth.
Interesting.
It's it. I cannot quantify. I don't think anyone can quantify it, but it's not a good idea to do certain things. Then, of course, if you focus only on CO2, you forget about this. Although we need more whales. See, big whales and more of them, and the more whales, the better it is.
I have to agree with you on that.
Yes.
Now, in the movie, you also said that the lifestyles we have now in developed countries is a result of the last 200 years, partly because of the Industrial Revolution and because of subsidies to the fuel industry. Okay, so what role do these subsidies play in the current crisis, and how or should they be changed to level the playing field for alternate forms of energy?
Yeah, we have good hopes that we can move to different forms of energy, because you see, energy is fundamental for everything. We cannot do anything without energy, and energy is what provides food for us. We could not have food. You said we are 3 days from revolution, or some people say barbarism is 3 hot meals away, or things like that. And so we have this problem, and you see it especially well if you look at it from a systemic viewpoint. Systemic viewpoint means that you see the whole system as a metabolic. Let me use this term. Metabolism is what you have. Your life is a metabolism. Plants, animals, living creatures, they all metabolize energy. They transform energy. So the system, the human system, the economy, if you like to call it this way, is a metabolic system. It starts with energy on one side, transforms it, and then it becomes waste. Both a problem, because we have too much waste on one side, and right now, too little energy from the other side. So the system is becoming unstable, and you have energy wars, for instance. That's what we're seeing right now. People are doing the things they're doing, unfortunately, because there is this problem, supply problem.
Right.
Not anymore so abundant as it was, say, 50 years ago. We're not running out of fossil fuels. Not now, not in 10 years, but in 30, 40, 50 years, we start having very serious problems.
Right.
Problems of supply. Absolutely not to be discounted. We are having, and already now we have them. It's gradual. There is not a moment in which we run out. Oh, we run out of oil. Oh, what is the oil? Well, look, this is the well. No more oil. What's no? It's not going to happen. But the situation is worsening by the day, as you have probably noticed. And so we need different sources.
In the movie, you also compare human civilization to the Trevi Fountain. The water gets pumped up and it comes down, and you compare that to the human population. You say it can go up and up and up, and most likely it's not just going to level off. It's going to.
Yeah. This is a good metaphor.
Would this be like an explanatory metaphor for the Seneca
It
effect?
is. It is. Absolutely. You have it. Seneca. You could see this as a fountain, water going up and then down. That's exactly as you said, because the fountain is a very good metaphor, because in order to raise the water up, you need energy. And then it will go down by itself, because it dissipates a gravitational potential,
Right.
if you like to use these terms.
Okay. Now, I'd like to change the topic a little bit to solutions. Now, in your resiliency.org website, you have an ACT link that I clicked on and was checking it out. And it said there are 5 ways to take action. You want to tell us a little bit about that?
Oh, well, I'm not sure I remember exactly what are these 5 ways, but essentially what I say is that facing a problem, you have probably more than 5 ways to deal with it. But I think the fundamental one, very fundamental, is that in systems, when you study systems, you see there are no problems and there are no solutions. There is only change.
Okay.
So you can oppose change. Oh, no, I don't want it to happen. Or you can let it go. Okay, we follow. Maybe you don't like it so much, but we follow. And those are the 2 main strategies. You cannot avoid, actually, the Seneca cliff. Yeah, nobody wants to fall down a cliff.
Right.
It's the main result of trying to stop the change. If you stop the change has to happen. Eventually breaks and happens. So you have to understand the system, go with the flow, and follow. But you understand that the system is expanding or contracting or doing things that you like or you don't like, but only as long as it has energy in input. Like you can do a lot of things. You, John, can you dance?
Well, I've been told not, but
I used to a little, but we can do a lot of things. You could dance if you like, you can, but in order to be able to dance, you need food.
Yes.
Otherwise you cannot. You say the problem is that I didn't start. No, if you don't, first you need food, then you can learn how to dance. And so there is not the problem, but it is a flow. It is a movement in some direction. You want to learn whatever you want to do, to rock climbing or whatever, or anything. And so we have to understand that the society is a complex entity. First needs energy. That's essential. Then you can do things.
Right. Okay.
And go work for a better society.
Right. What caught my attention about your 5 actions were it sounds a lot like I'm involved with Jane Goodall's Roots and Shoots program. And it's about students doing service projects. But there's steps to take before you can do the project. And one of them is, what's going on in your community that you can work on. So for Roots and Shoots, we do a community map. We write down the assets, our need, what we have, and then figure out what your needs are. Then you can do a project. And that looked exactly like what was going on in your actions too.
Yeah, you need to plan. The system goes in step, as you mentioned before, like a fountain. Can go in steps, like some Italian fountains that are famous in Rome, or things like that. And if you have resources, you can improve. If not, it becomes very difficult.
So we're getting close to running out of time here. So I just want to ask you one question. What gives you hope for the future?
See, it's something again that Seneca said, the philosopher. I've been a little bit influenced by Seneca, as you may imagine, because I keep mentioning his name. Maybe I show you a portrait of Seneca.
Okay.
This is the whole work of Seneca. A lot of stuff he wrote, and he said many things about the ruin and misfortune. But he said there is no success that was not originated by an earlier failure. See the point? So it is a very difficult moment for humankind right now, but maybe, and I hope it is the point which will allow us to grow again and to learn from our mistakes.
That's like, as a science teacher, we're doing experiments, and the one thing I always have to tell my students is that science is an experiment, and you're not always going to be right. You actually learn more from your mistakes than you do when you get it right the first time. And like you said, that's a hard thing to understand.
Yeah, it can be understood, I think.
It can. I think so too. So I just want to thank you again for taking the time tonight.
Thanks a lot. It's a lot of fun.
It's been a real pleasure. And I want to thank the 12th Hour and Vanquish Media for putting this live stream together. And I want to leave you with a quote from my good friend, Dr. Jane Goodall. And Jane says, quote, "You aren't going to save the world on your own, but you might inspire generations of kids to save it for all of us. You'd be amazed at what inspired children can do," end quote. And I think as educators, we believe that with our hearts.
And we can also be inspired by them.
You're absolutely right about that. Okay, thank you all for being here tonight, for all this or any of the other interviews that were conducted this week. And I hope you come away with a better understanding of the climate crisis and are willing to learn more and take some action. Thank you all for being here. Thank you, Ugo. It's been my pleasure talking with you today.
My pleasure too.
Thank you.